Good evening, one and all. Myself Sanket Agrawal. Today I am here to give a presentation on edge detection. This is mainly based on digital image processing. Topics to be covered in this presentation are introduction, block diagram, edge detection, types and techniques, input and output. Applications are fingerprint, satellite images, robotic visions, and medical science. Introduction to digital image processing. Digital image processing is the use of digital computers to process digital images through an algorithm. It allows a much wider range of algorithms to be applied to the input data and can avoid problems such as build up of noise and distortion during the process. Image process is a method to perform some operations on an image in order to get an enhanced image or to extract some useful information from it. Digital image processing is among rapidly growing technologies. Image processing basically includes the following three steps: importing the image via image acquisition tools, analyzing and manipulating the images, output in which result can be altered image or report that is based on image analysis. Block diagram. This is the basic block diagram of edge detection. The first we have taken input image, then the image is the image is read by that read image, then it is measured at detection and perform operations, search logical directional maxima, and then smoothing, thresholding, edge leaking, and lastly edge director image. Edge detection. Above changes in intensity of pixels. An edge is defined as a sharp change in pixel values in the range. Edge provide boundaries between different regions in the images. These objects boundaries are the first step in many of the computer vision algorithm, like edge-based face recognition, edge-based obstacle detection, edge-based target recognition, image compression, etc. Here's a small example of edge detection is in the first figure. There is a original image. By doing edge detection and image processing, we get an edge detection output as seen in figure number 2. Types of edge detections. There are three types. First one is step edge, second one is amp edge, and third one is roof edge. The figure shows an example of medical field related example. This is a human skull in which all three edges are needed. All three edges are useful. A shows the step image, B shows the ramp image, and C shows the roof edges. Steps in edge detection. First one is filtering. Filter images to improve performance of edge detector, which respect to noise, suppress as much noise as possible without destroying true edges. Enhancement. Emphasize pixels having sufficient change in local intensity to enhance the quality of edges. Detection, or it is also known as identify edges. Thresholding, determining which edge pixel should be discarded as noise and which should be retained, that is threshold edge magnitude. Localization, estimate edge, determining the exact edge location. Techniques. There are different techniques used in this edge detections. First one is robot operator, sobol operators, private operators. The first matrix is of robot operators. In this, the diagonal matrix in this matrix, the diagonals of the first image get converted and get adjacent in the second image. And in second figure, that is sobol operator, in matrix the rows becomes the columns and the columns become the rows. Means by performing using sobol operator filters, the number of rows become in the first matrix will converted into columns in the second matrix, and the number of columns present in the second matrix will be converted into number of rows in the first matrix. The same operation will perform in private operators. Types of filters in edge detections. Sobol filters. The Sobol operator, sometimes called as Sobol-Feldman operators or Sobol filters, is used in image processing and computer visions, particularly within edge detections algorithms, where it creates an image emphasizing edges. Pivot filters. It is a discrete differentiation operator computing an approximation of the gradient of the image intensity functions. The result of pivot operators in either corresponding gradient vector or the norms of these vectors. Robot filters. The idea behind the robot cross operators is to approximate the gradient of an image through the discrete differentiation, which is achieved by computing the sum of squares of the differences between diagonally adjacent pixels. Canny filters. It is used it uses a multi-stage algorithm to detect a wide range of edges in the image. It was developed by John F. Canny in 1986. Canny also produced a computational theory of edge detection explaining why this technique works. This is the Matlab code which we have performed in edge detection system. Here we have taken input as a X-ray of a human leg, and by using Sobol filter in edge detection, this will get the output of it. This is a demo one. The applications used in edge detections are, first one is fingerprinting. At present, fingerprinting recognition has been used widely, such as in mobile phones. Edge detection technique enhance the quality of image and cause improvement in the image recognition. This is one application in edge detection, that is fingerprint. Mostly nowadays the fingerprint is more widely used in various appliances and various devices. Examples: mobile phones, laptops, PCs, or any other equipments like doors or security purposes, walls, etc. So in this the fingerprint processing image is taken, and by using various filters like Sobol filter, robot filters, or pivot filters, these are the different outputs we get from it. Second application is satellite image. The edge map generated by bilateral filtering based edge detection contain more accurate and well logically edge mapping, localized edge map. It also suppresses noise and produces more realistic edge mapping. Here our second application is satellite image. We have taken a image, JPG image, that is satellite image, and by using edge detection, we had converted into by using Canny filter. We had get output on it as this seen that the edges of the these are the edges of the original images. Third one is robotic visions. The present and near future main application areas of edge detections are robotic visions. Example in self-driving vehicles. Set the steering vehicles angles based on a picture of the road. Here we have taken an example of self-driver vehicles in robotic visions. As you know, we are moving towards the automation and we are moving towards industry 4.0, in that most of the things are based on automated. So in this, robotic visions are highly used, and by considering this, we had taken an example of self-driving vehicles. In that we had taken image of original image of self-driving car, and by detecting the car by applying filters and edge detections, we had get an output at the center. Fourth one is medical science. Another important area being developed, which of courses involves edge detection, is finding pathological objects in medical images such as tumors. Medical image edge detection is an important method in the recognition of the human organ, and it is an important processing step in 3D reconstruction, such as reconstruction of brain images. Here we have taken an example of medical science, as nowadays in medical field also digital image processing is widely used. So here we have taken an example of MRI scan of brain, which detects the tumors, or we can identify the tumors in the human brain. The image is taken, the image is scanned as MRI scan, as we taken as input image, and by applying Sobol filters or any other filters, using edge detection, we get an output. By original image we get an edge of the human skull, as present in the figure. And the second image is canned image. Here we have uh, get an accurate edges of the original images. This is a GUI layout. In this we have created a GUI, which is of edge detection system. In this we use push buttons, access, pop-ups, and static test. There are operations on push button 1 and push button 2. If we press push button 1, then it will select an image, and by applying filters, different filters, we get an output of it. After implementation, this is a result we get from GUI. By selecting, here we have selected an example. Here we have selected an image, that is a X-ray of human leg. After applying Sobol filter, we get an output, that is Sobol filter output, that is in ages form. Here we have taken a video. This is a GUI code. In this this is a code. If we create a GUI at the backend, it will create a code. In that we have different functions, as and it will performs push button 1 and push button 2 operations. In this, these are the push button 1 and push button 2 operations. Here is the operation of push button 1. As we see in that, there is a global gray image, and at the 88th line we have selected a file or a path of the which we have selected to which we have get an input image. By applying a grayscale image we had selected in it, and we use a universal image, that is, it may be RGB image or a black and white image. Then it is converted into RGB image, and by pressing second push button, and at the second push button, there is a code. This will convert the gray image in a edge detection image. Here we use a switch case. At each and every cases there is a different filters. At switch case 2 there is a Sobol filter, and switch case 3 there is a preview filter, robot filter, lock filter, and candy filter. If we do not apply any filter, then it will display as no filters. By doing this, we get an output by applying any images on it. This is a GUI of edge detection system. Here we have selected an image, that is X-ray of human leg. Then we have different filters. At each and every filter there is a different operation performed beside this. So by selecting Sobol filter, private robots, lock or canny filters, we get different robots. If we select Sobol filter, then this will get as a output. If we select private filter, then it may change in this. As we select different filters, it may get changes in it. And lastly, when we use canny filter, it will show an accurate edges of the X-ray image. Thank you so much. This is our full presentation based on age detection. Thank you.